this is a little humorous, so is this. But yeah, it's going to be bad. So, yeah. Thank you, sir. Yes, you got it. Though actually, it's a bit larger than life up there, so slightly. So that's this bone in the arm. That have that particular model here and made that and all these models on a 3D printer, and I'll get into technique and workflow for that in the course of this talk. So a bit about me, hacker. I've grown up with a number of people I see in this room, number of familiar faces over the years. I'm a physician. I graduated medical school last year, and I'll be starting my residency this coming year in rehabilitation medicine at University of Texas, San Antonio. And I end up traveling a lot and doing random things with both those skill sets in a number of different locations. So this project too kind of came out of that. So things I'd like to talk about, talking about the file format of how medical imaging gets stored, and two of the major kinds of studies I'd like to talk about, CT and MRI. Those are the most useful from a 3D modeling perspective about giving a 3D picture of the human body. Talk about some of the workflows. All the research and modeling I've been doing off my MacBook here. And a lot of the software other than Mac OS is all open source in one form or another. And talk about some of the applications of 3D printing in medical life. So out of everyone who's here, show of hands if you've ever had to have a CT or an MRI for anything, for any reason. Anyone here had to have surgery or been hospitalized? All right, so good over half the room. Any healthcare professionals here? I see 1 and 2. And for those who've had to have medical imaging, did your physician treating you, did they look at the images with you? Show of hands. Mm-hmm. Did you feel you understood it with that conversation? Okay. How many people here have a copy of their medical imaging? Sweet. Somebody did their homework. So yeah, I'll go into this again in a moment, but yeah, getting a copy of your medical imaging is part of your rights as a patient, and it's also covered under law. So release of records is a good thing. So things we'll not cover. This presentation will not make you a radiologist or any other kind of physician. 3D basics are better covered in other talks and other presentations, and wealth of material online. And yes, there is no one-click headshot with this. It is a process of defining what do you want to print and understanding the imaging and the anatomy. So I'd like to provide a bit of that background. So yeah, just overview top to bottom. Imaging taken with the CAT scan or the MRI machine, the big loud noisy things that look like this. This is an MRI machine, not to scale, well, not true to size, but pass this around. Actually, well, fooled you. This is a big magnetic coil, and the imaging system is in here. And this part is the bed or the gantry. It slides through with the patient on it. The process can take anywhere from 20 minutes to an hour. I'll go into the modality in a bit. They're loud, they're noisy, they're expensive, and yeah, if you don't take off metallic objects, yeah, they can fling them at very high velocity. It's fun video. But I'll see if I can pull that up later if I have time. So the imaging's taken by the imaging center, stored on a server there in both the DICOM. DICOM is both a file format and a transfer protocol. Discuss that a bit. And PACS is Portable Archiving and Communication System, I believe is what the acronym stands for. So DICOM, you can think about it as the PDF of medical imaging. It's a container file format that's pretty well defined and pretty ubiquitous. So you can, nice thing is with that, since it's been a pretty stable file format for the last 20 years, there's a number of different viewers that you can view your imaging with, and then export that into a workflow suitable for 3D modeling and 3D printing. So this, from here on, is that's pretty common with any of the 3D modeling and 3D imaging workflows that people are working with now. Well, I initially came into this by trying to I was introduced to 3D printing at i3 Detroit in 2011, and I was trying to figure out, well, what can I print? And then I realized, oh, medical imaging kind of works in the same way, so started exploring on that. So this step here is, I guess this is the juice of what I'd like to cover here. So the problem that I think can be addressed with the idea of 3D printing in medical imaging, well, taking a step back, show of hands, familiar with 3D printing? Yes, no, maybe? Okay. So I like that in the last couple of years, it's really emerged as an inexpensive and practical way to actually build physical objects, which is going to be a game changer and is a game changer on a number of different ways. So stepping back from a medical perspective, radiology, imaging is one of the fundamentals of how we learn and practice medicine. It's taught as part of medical school how to read basics of different studies, X-rays, CTs, and MRIs. And then depending on one's specialization, their residency field, you end up learning more imaging specific to your modality. Or if one goes into radiology, that is your area of expertise. And that can be a 5 years residency, and it's relatively competitive. So tricky stuff to learn. And yeah, it understands a lot of understanding the modality, your patient's physiology, what you're trying to image, and what tools you have available to you. Yeah, about 1% of physicians are radiologists, and even fewer patients are radiologists. So it's frustrating when we try to communicate stuff on screen, and I know I'm frustrated as a care provider showing people something on screen, and it's like, well, if you look at this blur here, this blob means something bad, but this one doesn't. And yeah, I'm not a fan of sloppy communication like that. So yeah, it's why do we practice medicine like this and have video games that may contain inappropriate content for children? But this is a CT scan of an abdomen, and they're shown head to toe, and they end up being slices, or there's slices going through the patient, so looking top down, and this is at about the level of the hips. But it's black and white, it's hard to read, it's boring, it contains a lot of information if you know how to read it, and it's not engaging per se versus GTA 5. So I think there's, between on-screen visualizations and actual in-person or tangible objects, there's room for improvement. So why should we do 3D printing in medical imaging? Yeah, because we can. The technology is available. I've been able to, in the last 2 years, learn a fair amount with relatively inexpensive and very available hardware and information. And as a care provider, I think this can really change how how we have the doctor-patient conversation. And it's, there's a lot of work I see in 3D printing and 3D modeling on physician-focused tools or surgeon-oriented tools that are aimed back towards other healthcare providers. But my interest in area of research right now is how can we make this a better patient education tool? And yeah, we can make personalized, tangible models of a patient's physiology. And this is something everyone here could do with their own imaging on their own computers as well. And yeah, there is a lot to be said about having a tangible representation of an injury. It's, yeah, by making an abstract concept like, oh, you have a broken bone in your leg. You can't see it, I know you can feel it, but you've got something going on there, and we're gonna do a bunch of stuff and hopefully fix it. It's, again, it's a vague communication versus this is what's going on. This bone here is this bone here, and you have a fracture right here, which correlates to here. And so what we're going to do will be, and then describe a procedure. Or even just like that model of the ear, whoever has it, Audrey? Yeah, so that model of the ear, trying to explain the anatomy of the inner ear, it's difficult when all you have are two-dimensional flat representations. It's easier to have a conversation about a physical thing. And also, it's not technology mediated. It doesn't involve, oh, we have to stare at a screen together, and then all of a sudden, my body language is facing the computer, not the patient. So, yeah, briefly, with 3D printing, it's, well, with DICOM images from a CT or an MRI, they're stored as stacks of images, and it's similar to how a 3D printer, like this printer bot is working, it's drawing in the X and Y axis by moving the print head and then elevating and building on top of that. So there are two processes that are a natural complement to one another. And we're, with working with imaging data sets, figuring out how to make a polygon vector model out of whatever region of interest you're trying to talk about, that's been the tricky part. But it can be defined manually or some shape recognition algorithms as well that are built into a lot of the viewers. But there are also some free, like Creative Commons licensed data sets where people have already done that dirty work for us and released it as a Creative Commons product. Like this humorous was from a data set I was able to download and print directly to my printer at home. So yeah, with getting a release of records, getting your own records, I advise every friend of mine and everyone I meet, get a copy of your records if you've been hospitalized or had a treatment for anything or had a study. And those records, they're part of your right as a patient. They were explicitly covered under HIPAA in '96. And you can do a release of records form, and in the case of if you have a CT or an MR done at an imaging center, I'd say talk to the imaging center about it, but they're obliged to give it to you within 30 days at a nominal cost. And every center has its own release of records form, but they are self-explanatory in many ways. Medical centers sometimes can be a bit obstructionist about releasing your records to you, but it's know your rights as a patient, and they're worth having for the future as well as to experiment with something like 3D printing. So I covered a lot of this before. The DICOM file format, that the container file that all the imaging gets stored in, it's a well-documented, complex data set. And it's standardized across imaging centers worldwide. And a lot of metadata about how a study is shot is stored in there. So, oh, there we go. So a lot about when it was shot, the type of machine it was shot on, the serial number of it, whether the study involved any contrast agent, but there's also a fair amount of personal identifying information about a patient that can be stored in here too. So that's just an aside from a privacy perspective to keep a hold on where your imaging gets distributed to. Oh, they'll be back. No, there. All right. So with CAT scans, you can speed through some of this to get to the actual workflow. CAT scans are a series of X-rays shot through the body, usually head down or from top to bottom of whatever the region of interest is. And then those get assembled in a DICOM file. And you can get decently high resolution with those. I know for studies of like a sinus, those can be at slices at about a 0.5 millimeter thickness. So for a 3D printing perspective, your resolution, it's a workable resolution for building stuff with a 3D printer. And as far as the colors on a CT when they are black to white, that range is a standardized scale. Units called Hounsfield units, named after Sir Godfrey Hounsfield, who built the first CTs. The cool thing to know is the colors for the different kinds of tissues are uniform in a grayscale from black to white. This is, well, the range goes from -1,000 to +3,000. And -1,000 is defined at how X-rays appear, or appear when they pass through air. 0 is defined as how X-rays appear on the other side when they pass through a reference volume of water. And through that, and it's a linear scale. Nice thing is different kinds of tissue appear uniform on different studies if the study was shot correctly. So this is cool from an imaging perspective on if we want to build something and know that, oh, I want to build a model out of bone. You know that bone is going to show up in a certain range of density, like from about 400 upwards. And then if there are metal implants in the patient, that's, those will show up in there as well, but at higher densities. So looking at studies, you can, yeah, that becomes relevant when analyzing them. Interesting side note, the research stuff for CTs ended up being funded by EMI by the money that was raised by the Beatles' success. So, yeah, I just came across this today. So other imaging technique, yes. Thank you, ICP. So yeah, with magnetic resonance imaging, the whole body is exposed to a strong magnetic field that polarizes everything in a north-south axis. Then all the molecules in that area are hit with an RF frequency that knocks some of the atoms out of that range, and then they remagnetize. So that signal when they get demagnetized to remagnetized that's different on different kinds of tissue and of different molecules. So it's the same, this is just an imaging technique from, it's the same as hydrogen NMR in chemistry. So, yeah, different studies, different reasons. You have, the main things to know are MRI, it's intense magnetic fields. You don't want to use it unexpectedly with metal, because the metal will either heat up or get thrown. Some of the software that I've come across, 3D Slicer, it's cross-platform, and it's it's more aimed towards imaging researchers. I've been using, it's a fully functional toolkit. I've been using Osirix, however, and this is more geared towards medical users. It's set up as an imaging station would be for reading radiology. Also, there are some great on-screen visualizations that I've been able to do movies and show patients their anatomy with that. On the commercial end, Materialize, they have a pretty nice product called Mimics that's about 18 grand for a single seat license, too rich for my blood. But this is big in people designing bioimplantables, prosthetics. This is a one-stop shop to go from a medical imaging to something that's fit for print. So when defining a region of interest, and yeah, it's always try to figure out what story are you trying to tell. So wait for this to resync. So in Osirix, again, this looks very similar to any work set or any workstation I'd be using in a clinical environment. And knowing what story you're trying to tell is important when building something. So this was a data set I downloaded that's, make sure it's the right one. This is a 46-year-old woman who had she has a lot of complex fractures on her right side. Yeah, with reading CTs and MRIs, it's always as if you're looking from the toes up at the patient. So, yeah, nice and confusing. This is the patient's right, that's the patient's left. So if you just watch with the hips here, that's this side, patient's left is normal, and you can see that there's some complex fractures on the right side. That kind of starburst stuff is because all this was surgically corrected as well. But yeah, normal, not normal. But, and this is, as far as defining with a region of interest, with building a model, part of, well, if we wanted to export some of this to a 3D modeling program, it's an issue of, just like in Photoshop or image editing, lassoing a certain area or drawing it, or if there's a way to magic wand this. In a lot of the imaging software, there is, regions of interest are pretty important pieces of information for trying to figure out the volume of a bone or a tissue. We can use that for 3D printing to select a region. And so here, this is in Osirix, which is just for Mac OS, released under an LGPL. But I can define a region and pick a contrast ratio around it. And goal being, try to select enough of that tissue, in this case this bone, and to have it show, be able to build a model out of that. So this is, while the tools are available, figuring out how to tell the particular story with your patient can be very specific per study. So Osirix also has some presets built in that work decently well, but require some cleaning up for doing surface renderings. So you pick a density of tissue, and Osirix will build a surface model out of that. And that can be exported into a 3D printing workflow. And there's one other plugin I found that called MIA, Multiple Image Acquisition, I believe, that defines regions of interest with in Osirix pretty well. And that plugin's available free. So, let's see. What had caught my eye with this was that Osirix, when you do surface renderings, you can export to STL, which is, it lets you go into a lot of different workflows for 3D printing to clean these up. And from there, I've been able to design a fair number of pieces here. And let's see. So yeah, 3D printing, that's outside the scope here, but I'd been doing a lot of building with a MakerBot replicator and had decent results once I calibrated it somewhat obsessively, and it worked out. So one thing I came across this past week while researching for this was this data set through a bioscience group out of Japan. And it's a Creative Commons licensed data set where they've gone through, did a full body MRI of a patient, of a subject rather, and tagged all the bones, all the organs, all the different components one would like to describe, and mapped them out as polygons, and made all that library free for download and available under a Commons share-alike attribution license. So this is great because rather than, I was spending a lot of time these last few weeks and months trying to define the different regions of interest myself, but finding that I could just go to look at a library and pull up, be able to pull up, oh, I want to print out a trachea, or I want to print out the thyroid cartilage that goes around it, and print those out at life size for someone, such as myself, and have them be, I didn't have to worry about a lot of the imaging. I didn't have to worry about finding my own data set myself. So this is, as far as areas I'll personally be utilizing this, will be talking with patients and building models even just to better understand anatomy for myself and my colleagues. There are other free data sets with DICOM data that are available. Osirix, off their website, has a number of cool studies where they've curated those and de-identified them. And National Cancer Imaging Archive has thousands of studies that I haven't scratched the surface of what's available there. With this model, just for some context, this is the thyroid cartilage. You feel your throat, and the bony part that you kind of feel clicking if you move your finger back and forth here is this. And your trachea, your windpipe, is behind that. The vocal cords are protected by that. And I printed this out in particular to show the anatomy, in particular the cricothyroid cartilage here. With in a emergency or in a long-term care situation, sometimes an airway needs to be established by cutting here, and it's all location, location, location. It's a difficult thing to learn, and the consequence of doing it wrong is kind of bad. So having a life-size model to work with as another teaching tool is useful. So, and yeah, don't try that one at home, please. Let's see. So briefly, as far as with my 3D printing stuff, I've got stuff set up in a spare bathroom right now. It's maybe a 6x8 room with the printer on a rolling cart. And it's been working. Main issue I had was isolating for temperature and isolating for vibration. So just advice to anyone else getting into 3D printing, I've had the best results with just being able to isolate as much as I can. So the printer from the ground up, I have foam pads, then a Rubbermaid cart with about 200 pounds of bricks on it, and then the printer itself is on another layer of foam and some wide feet. And then I have the whole unit bungeed down to the cart. So it isolates from vibration from outside in the room and dampens a fair amount of the machine's motion itself. So I can do some, I was planning on doing some live demos here on going through a data set and getting something fit for print. I can take any questions if anyone has any. Go ahead.
As far as, well, I have two questions, but as far as what you have from the DICOM, I have a couple, or as far as what you have from the DICOM, and as well as, I know like an imaging department is obviously going to have like a more of an IT team behind it. Would this be something that's feasible for a hospital to require another couple of jobs of people that can actually go through, get these documents, and translate them into a 3D environment, or a 3D actual thing? Is that going to be worth it just for the patient, or is this going to be more so used as an education tool for doctors, or as they're learning, or as they're new procedures, things like that?
So I see there's a case both from a patient satisfaction perspective and for a patient education and then compliance perspective, if in providing better education and better treatment, or better education to patients through 3D modeling and 3D printing. I think with a lot more focus on patient satisfaction and outcomes in medicine, I could see this being another teaching tool that might bring patients more on board with a treatment plan. I foresee 3D printers are going to become more available and more reliable, less DIY, while this will always be a sector of it. I'm looking at, I envision in 5 to 10 years, I'll be able to have a model made on demand in whatever care environment I'm in.
Okay. All right. And one last one about your setup in the bathroom.
Yeah.
Did you find that humidity was an issue at all?
It's, so I'm living in South Florida right now, and humidity has been stable in that room at about 53%. I have a $10 Home Depot thermometer set up in that room, and its humidity range has been about 50 to 58%, and temperature range 77 or 74 to 83 Fahrenheit. I found with printing, I switched from ABS to PLA printing about a month ago, and that solved a fair amount of the temperature sensitive problems I was having with ABS. But I know PLA will absorb humidity, but I haven't noticed a change in print performance with that. Initially, I did have my printer set up in my friend's hackerspace in a warehouse, and so that was basically outdoor environment conditions. And I felt a lot of the print quality problems I was having were humidity related. So yes, humidity is an issue. So, wherever.
Now, are you saying you can print any part of a human body?
Sure.
So you can print an entire human body, right?
In theory.
I mean, now can I pick a particular one, or?
You can. It's you
as
can,
long as
yeah.
they've had a CT scan.
If you had a CT or an MRI of it, yeah, it's something you could do yourself or work with someone else working.
I mean, I'm not
3D
trying
modeling.
to be creepy.
Right.
Yeah.
But yeah. So yes, there's a business case for that too.
As far as your data sets, do you accept, like if I were to provide you with my CT films as a tool, would you accept them?
It's, we can talk about that offline as well. What I'd like to do is have a waiver just discussing that there is PII involved in the data set, and I'll anonymize. There are methods to strip the data set. But
I was going to say, because I've exported the images out of my DICOM sets, so there's no metadata attached to them. It's just an image set, and they're all numerically listed, so you can technically throw them in a slideshow.
Yeah,
But,
it's something,
because I've got
to explore
like
that with you.
a dozen or so films of mine and a complete stack of films.
Okay, do you have those with you here? Or?
I have the images on a server at my house that I could
accessible, yeah.
I could very easily access them for examples or to transfer them to another server if that's easier for you.
Right now, with the data sets I have here, I have them stored locally. But yeah, it's something I can import them here, and if you're comfortable sharing them, then yes.
Anything for sake of science, considering the fact that there's a couple of interesting ones there that make most people cringe.
Oof. It's, let's see.
Couple of questions. How, for example, with that CT of the pelvis that showed the pelvic fracture and clearly some hardware trying to hold that fracture back together again. If you were to take that image or that stack of images and print that, how much work would it be to subtract out the metal?
It's subtracting out the metal. You could do that with defining when the region of interest is defined. Okay. Since the metal shows up on a CT as denser than bone, you could set an upper bound for, hey, define this region of interest just as, bone, but less than metal. Okay. And you could also define the metal as a different polygon set and print that as a separate 3D print.
And then put it together.
Yeah, and put it together. Cool. Or with the dual extrusion setup, you could print those as one integrated piece. Okay. Or two different densities of tissue you could do with the dual extrusion setup, like printing the lungs and the ribs, or print a heart as with one color of plastic and the lungs as another.
Okay. Speaking of lungs, seeing as they are largely air-spilled spaces, how hard would it be to print out a relatively airy representation, like a cross-section, let's say if you wanted to show a lung mass or a lung cancer?
It's, you could define, let me see, I think I have a data set with a lung or a lung CT. But one of the problems with 3D printing from medical data, it's it's more of an output issue with the 3D printers, is since the way the printer is working is by drawing with a plastic of a uniform density, and it's drawing strings of it across building something floating in free space can be difficult. You can build it by having scaffolding around it, and then you cut that away manually when making your model. With a lot of these, that's how, trying to think if I have a good example showing that. It's doable depending on, it's more of an issue of how one's doing their post-processing in MeshLab or SketchUp or some of the 3D modeling software. So, did that answer your question?
Pretty much.
No.
It just means probably not going to get alveoli.
It's doable to, well, with the lungs, like building a solid mass of, well, I built, like, this is a set of lungs, actually. Pass these around, too. But, yeah, a few days ago, yeah, I was waiting for my printer to cough up half a lung, literally. So, but these I just printed as solid objects. I could have printed a, I guess, print a subsection of it or put a tumor mass in red on it, but there are some translucent plastics one could print with as well, and that could also address the issue. So, anyone else? So. So, I can, let's see, with this data set, I'll see if I can find do a surface rendering with this one. So this is that pelvic fracture data set as well. And this is after the surgery. It looks moth-eaten, but that's an issue with how the thresholding was set here. But you can see the break on, actually, have a model of a hip as well. Pass this around. Yeah, I believe that's the inferior pubic ramus is fractured on this patient. And it's nice thing is with this, like this was a very quick and dirty grab of defining a pixel range and building a model out of that. Like I just, at this point, I'm just ballparking it at lower end of where bone shows up on a CT. And I'd be able to export this as an STL file and be able to open that in, I've been using MeshLab for a fair amount of this. One of the frustrating things I'm finding is the interface for a number of these programs is different per program. So it ends up being like I'll end up hopping between a few different workflows for a print. I can show some others. Let's see. This is from that same data set. Well, I tried subtracting the parts other than, well, this is the non-broken side, and this is half of the hip, like from the midline to the right. And you can do cleanup in programs like MeshLab or NetFab to make it fit for print. Let's see if I can pull something up from that, the Japanese data set. If there were any take-home I'd like people to have specifically from this is that this body parts 3D data set, it's available and really well curated and defined. And this is something you can open in a 3D print program, and like this is, I just click this at random and it happens to be a segment of the lung. And so if you want to start building your own derivative works that from a Creative Commons licensed data set, there's a full body to work with. So that's one of the thoracic vertebrae. And yeah, it's a great way to jump into this. That, and then also in Osiris, being able to export STLs from any specific imaging. So, I don't know, I can keep rambling, or people can take a look at some models, or I can pass stuff around, or open floor. All right, thank you.